Let's start by having a look at the parts that have arrived. I'll show you the parts separately in a moment, but I've just literally checked them all over and they're spread all over my bench. This is the component side of the main printed circuit board, and I've got it mounted in my new toy specially so I can do this. All the components are well marked, and I don't anticipate it at this stage having any problems in building this kit. I must admit it's nice to see these old TO3 style metal transistors. In many respects they're so much better than the plastic devices, mainly because the fixing is from either side where you can screw the whole thing down, and the bottom is mostly, well, metal apart from the insulated area here. I always think these are a better transistor than the plastic ones, because the plastic ones are like this. They just have one mounting hole and you clamp that down, but the transistor itself can lift up slightly and come away from the heatsink. So 10 out of 10 for using this type of power transistor. It depends on who you speak to as to whether this kind of insulating washer is better than the more conventional mica washers. I must admit, I guess it's because I'm old school, but I tend to like a mica washer with silicone grease on. But saying that, I've used this type of plastic washer on all my latest products, mainly because it comes with them, to be honest, and I've not found any issues with them. And at least you don't get covered in silicone grease, which has got to be a plus. These are some of the other transistors, not all by all means. It's nice to see that they're using this more modern and better chip than the original, can't remember what it was called now, but it's quite an early chip, and they were renowned for their noise and relatively poor performance. So this is definitely a step up. The resistor quality seems generally pretty good. They're mostly 5%, although some of them are 1%. Quite a few 1 and 2 watt resistors here. Reasonably good quality electrolytics and general capacitors. The electrolytics aren't of a specific brand. They are relatively uncritical insofar as they're not in the signal paths. The ones that are generally pretty good, I would suggest. There are a number of chokes also used in this circuitry, and a bit more detail about that later, but they are wound on a ferrite core and look to be nicely made. They are different, by the way, that it's not just the colour. Now, something that is important is the heat sinking. Now, this isn't actually the heat sink as such. If you look on the back of it, it has holes, and this is meant to be screwed to the heat sink. And the idea is, if I put the PCB over it, the power transistors collects the heat and transfers it to the heat sink of your choice. There's also a range of diodes and other bits of paraphernalia, like these little terminal blocks, and a range of screws and nuts and bolts. I don't propose to show you those in great detail. There are 4 fuses, by the way, which is nice to see. So it's a reasonably good kit, and again, I don't propose to show you me soldering all the components on, but if I find an issue or something that needs to be spoken about, I will film it and show you. Something rather nice that I discovered, it gives you values of the capacitors here, because some of them are marked. It's like this one here, 330 picofarad. is marked 331. Now that one isn't much different, so fair enough, it could be. But here, for example, 1 nanofarad is actually 102, whereas on the board it's marked as 102, and on the capacitor it's marked 1N. So you can always go and work these out for yourselves, but it's really nice that it's actually printed on the back of the board, because there's no instructions with this whatsoever. Everything seemed to make sense, particularly when you've got these conversions. Here I didn't have any parts left over. Now, when I come to make the second board, I do have a small problem. I've managed to break this. This is the driver transistor, or one of them. And the problem is, it's when you mount it on the heatsink, you have to have fairly sharp bend in the lead out cables to go through the board, and the board is actually fairly thick. There's the driver transistor in question. You can see I've had to bend the leads fairly tightly in order for them to go into the holes. Now that in itself is not a major issue, but the wires from the transistor only just go through the PCB. And this is why you can see the heatsink that the transistor mounts on is actually quite thick, and then you've got to go through the board itself, find for the nuts and bolts, but the lead out wires are only just long enough to go through the board. The thin piece of wire is sort of spot welded onto this piece. It broke off. But that's not a problem, I can fix that. But just something you need to be aware of. Well, I've actually managed to mend it. Not rocket science, I've literally just soldered a piece of wire onto that leg. So I think that will be fine. The original piece that I showed you earlier is now somewhere on the carpet in here. I've just spent 15 minutes on my hands and knees searching for the piece of wire that came off, but it's gone to that magical place where things do vanish when you're building things, usually little screws and terminals, but I've just used a leg off one of the resistors to solder on. Incidentally, these are plastic transistors and don't require a mica washer, but what I would recommend is just a little daub of silicone grease. It will just help conduct the heat a little bit better. That's what the board looks like when it's finished. All I've got to do actually now is to deflux it and go round with my magnifying glass to make sure that there's no solder bridges or anything nasty. Oh, and the other thing that I've done, which is entirely up to you if you're going to build this, as supplied, the chip is soldered directly onto the board. Now, I've just put a socket on here simply because if anything should go wrong with the chip, they're a bit of a pig to get off. I know there's only 8 legs on there, but they are quite hard to remove, and I might experiment with different chips on here at some point. So that's my idea. We're getting dangerously near the time when we have to apply power to these boards, so it's a nervous moment for me. But there's a few things I need to point out. Now, you can see here there is a hole in the board. Let me show you another one. This is one I prepared earlier. This is tapped at M3 and is designed to connect an earth wire to the heatsink, because the heatsink is completely isolated from the rest of the circuitry. I've read somewhere the circuit can oscillate if the heatsink is not grounded. So whether that's true or not, I really don't know. But there is a hole there, radiator ground. So I don't know whether this has to go back to the zero supply, because that is the zero supply, the plus here and the minus here. And the center terminal there is the speaker connection. So I don't know why you just can't link that to there, whether that will form a loop. So for the moment I've taken a long wire, well, relatively long, and I'm going to connect that to the center point, or the zero voltage, just in case. These are 3 leads that I've made up for test purposes. They're literally about 14 inches long each, and I've put an insulated boot connector here, and they will literally plug into the various sockets here. Now I should be testing this initially on my power supplies. You can get 30 volts out of the plus and the minus, so that is the minimum voltage they suggest this will work at. But the main thing is I can introduce current limiting. The only other minor issue, it's not really an issue but something you should be aware of, let's just get a little bit closer. I mentioned previously that I put a socket on the IC here, and you wouldn't believe the amount of difficulty I had in inserting the chip into the socket. I kind of wish I'd soldered it straight in now, but I did the usual trick of bending the leads so that they're all parallel. But we finally got it in there after a great deal of really quite appalling language. So I'm rather glad I didn't do that online, because I'd be ashamed of the things that I was saying. Now, the other end of these leads that I've made up, I've just simply tinned them so that I can plug them into the power supply. But I have sort of color coded them. The ground is going to be green, and that goes on here. Nice and tight. And this is the positive supply, so the brown goes on there to that one. I'm glad these are nice and tight. And I've used the negative, I've used this blue, and that goes on there. So that's where the speaker will go, and I'm not putting any connection on there at the moment because I shall have the scope and the test meter on there simply to make sure we've got no volts, because at the moment I don't have a protection board for this. So if we get any volts on there and I connect it to the speaker, then it's goodbye speaker. This is the input terminals, simple plus and minus, so I should just connect a bit of screen cable to that. Well, it hasn't gone bang, and it seems to be working on the first channel I've tried, but I've got a buzz on there, as you can hear, and I've got to decide now whether it's coming from my external leads, because when I take the input off, I've got no buzz, and you can hear when I move the cable around, the buzz varies. So I'm not quite sure where it's coming from at the moment, other than the fact if I take the input off, which comes from my computer, by the way. But the whole thing is working rather well. I'll just put this on, it'll be quite loud just for a second or two, but mind your ears. See, it's clean. Just got to find out where the buzz is coming from. Well, I haven't solved the problem yet, but just to show you that it is coming from the input, here's the input, and I've taken the phono out of it, and if I put my finger near the input, you can quite clearly hear the buzz you'd expect to get. Right, well, I've solved my bum. I've solved my hum problem, and it's cheap Chinese shit plugs. And what it is, it's just a twin core and it's not earthed. Just to show you now, I've just put the sound on again. Mind your ears if you're on headphones again. That's enough of that, because it's copyright stuff. Now, because I'm using power supplies here, which are only providing 30 volts plus and minus, I won't be doing any power tests. I will be checking that the clipping is symmetrical, but obviously with such low power or such low voltage, it won't develop its full capability. All I'm interested in really at this stage is to check the frequency response and throw some square waves at it, and just to make sure it's not overheating or thermal runaway or anything like that. The first amplifier, or I should say the second one that I came to test, didn't work. Now, I'm ashamed to say it's my fault, because what I normally do before I apply power, apart from going around with my lens to check for joints and solder bridges, and then I would deflux it, but I'd run out of the liquid I used to do that, so I didn't do it. And if I had have done, when you scrub it with a toothbrush, this problem wouldn't have occurred. And this is the problem. Now, I'm zoomed in quite a long way, as you can see by the size of my finger, but that was the problem. And it wasn't a solder bridge or anything like that. It was just a little piece that I'd cut off. And because the board was laying on the desk here, that had got stuck between two parts of the track. And it was, all I can say is I'm glad I had current limiting on my power supplies. So that was it. That should be a lesson. Well, at my age it should have been a lesson I learned many years ago, but it should be a lesson to you that just a little bit of wire like that can make all the difference between disaster and literally, if I'd had it connected to an unlimited power supply, I think we would have had some of the old smoke. Well, as per usual, I have to point out that all the fuzziness and noise on there is down to the workbench and the digital scope. It's not there in real life, because the level I'm using at the moment is quite low as well. Now, that's the 1 kilohertz square wave, and I have to say it's not the best square wave I've ever seen, and nowhere near as good as the L12 or L15 that I've tested in the past. And it's a bit of overshoot on there, which you can clearly see. I've checked the calibration of the scope and the probe, and that is purely coming from the amplifier. This is a 10 kilohertz square wave, and the comment I would make is not very good, to be honest. Now, believe it or not, that's the 20% square wave. I thought I should tell you it's a square wave because it looks like a rather pathetic sine wave. And that's equivalent of about 3 or 4 watts output. And it's pretty terrible, to be perfectly honest. Well, that's our 100 hertz square wave, and it's pretty pitiful, to be perfectly honest. I'm disappointed in so many ways, because I know the quad has a reputation of being a wonderful amplifier, but that is a very poor 100 hertz square wave, and it's possibly due to the fact that the low frequency rolls off quite badly. Well, compared with a modern amplifier, shall we say. The frequency response, I won't go through it and show you now, but the frequency response is flat from 30 hertz to 16 kilohertz. Now, the upper limit on that might sound even more pitiful, but saying that, it's only a quarter of a dB down at 24 kilohertz. So it's, for all intents and purposes, let's have a look at it. A quarter of a dB, it's 20 hertz, the lower limit, and 24 kilohertz, the high frequency limit. So compared with a number of amplifiers, including all the ones I've shown you on this channel, it's pretty poor. But saying that, it's the way amplifiers were in the 80s. And I can understand why people think this amplifier sounds like a valve amplifier, a good quality valve amp, not a poor one. And I think this is partly due to the performance of it. The performance that I'm getting on here is better, to be fair, than a valve amplifier, but it has the same characteristics. Valve amplifiers don't make good square waves. And I think this is why people say that it lacks detail. And the figures that I've got and the rise time of the square wave would tend to prove the point. Now, I know these are clones, not the genuine quad amplifier, but the circuitry is similar, but using modern components, that I would suggest that the 405 is like this. They may be using better components, but the components that are used on here are alternatives, but they're not rubbish, i.e. the transistors have a similar spec or better than the original quad. I think this is just basically the way the circuit is. We're looking at a 1 kilohertz sine wave here, and it's purely to look at clipping. And I need to point out, I've mentioned it already, but I'm using the lowest voltage that quad or this board recommends, that is plus or minus 30. So what I'm going to show you may be due to that, because it's meant to run on 40 to 50 volts plus and minus. But when I crank up the power, if I can do it around the camera, have a look at the square, this is a sine wave. We're hitting maximum power, and you can see it's clipping on the top before the bottom. There's the bottom, and it's not the power supplies that's clipping, it's the actual amplifier. So I have to measure the maximum power. There is actually 40 watts into 8 ohms. Now, don't think that's a long way off 100, because I know that, but it's purely because of the supply voltage. I've got no doubt, in fact I know the 405 very well in its sort of legitimate form, if you like, and it does give just a fraction over 100 watts into 8 ohms. Now its performance, even the proper quad, into 4 ohms, it doesn't give a lot more power, I have to say, and I think that's possibly why I would say, and other people have said, that it lacks dynamic range. It's because of current limiting at lower impedances. Whereas I think an amplifier that gives 100 watts into 8 ohms should give 200 watts into 4 ohms, or very close. But the quad doesn't. Incidentally, I've tested both samples and both clip in the same way, because there are no adjustments on the board at all. So the quiescent current is what it is, and also the center point is what it is. DC offset's very low, by the way. I've got the meter rigged up now, and it's on the 200 millivolt scale. At the moment it's registering me, so I've got more offset than the amplifier. And we're across the 8 ohm load, and it's 1.6 millivolts, which I would suggest is a very low figure, particularly as there's no adjustment. So the transistors must be pretty well matched to give such a low center point or offset. The amplifier's now just sitting here doing nothing. The heatsink is pretty hot because I've been doing sine wave and power tests, but this shows you that it very quickly, as soon as you remove the signal, you're down to 50 milliamps, slightly less, and it's actually using 1.5 watts of quiescent current. So that's pretty good. So what do I think of the kits, basically? This is a sort of preamp, if you like, as to what my final conclusions will be, because I haven't used these things yet, and that's really what it's all about. But building the kit was fun and I enjoyed it. As per usual, I tested all the components prior to assembling them, so I knew that when one of the boards didn't work, it had to be yours truly's fault. Well, I am 72. I mean, you get a bit like this when you get older. Anyway, so no problems with the kits at all. Comments that I would make so far. I did tell you about this earth lead which is strapped to the heatsink. I found it made no difference whether it was connected to ground or not. This amplifier has got the lead on it, and whether it's connected to the 0 point or the 0 point on here or the 0 point on the power supply didn't make any difference to stability at all. And obviously once this is mounted into a cabinet, the heatsink would tend to be at ground level anyway, so it's debatable that you'd need this. I thought initially it might be as a standalone unit you would need it, but certainly on my bench I've not found there's any stability issues at all. Now there's a couple of other points. These resistors here, if you can see, I've stood clear of the board because I thought there's two of these, one here and one here. I thought these would run hot, but they don't. But these two resistors here, which I put flat with the board, do run hot. So if you're building these, you don't need to stand these off the board, but those two, I would suggest you should stand them off the board, and by quite a substantial. They don't get too hot to touch, and even in quiescent conditions they do get noticeably warm, and long term, I'm talking about years, you will find it will mark the board. And this is what happens when you look at old equipment that's been used for tens of years. It does damage the board long term, but certainly initially you won't have any problems at all with any of the components. These are plastic transistors. I've actually daubed a little bit of heat compound on them. I would like to see these with metal cases on them because they're all plastic, and plastic doesn't conduct heat that well, and they do get quite warm because I think from memory they are the class A drivers. I don't want to go into the theory of current dumping, but basically the drivers run in class A, which they often do on amplifiers, to be honest, and these just dump current. But there's no crossover artifacts at all. Couldn't see any, even at very low levels at high frequency. So from that point of view, it should sound nice at low levels. But we're going to do some listening tests over the next 3 or 4 days. So the next time I speak to you, I would have done these tests. Admittedly, at the moment, I haven't decided what to do with these boards because measurement-wise, they're not very good. Whether they get, this is the same people say that valve amplifiers sound good. but they measure appallingly. There's nothing good about the measurements of a valve amplifier, but people worship them. They think if they spent $25,000 on a valve amplifier, it's the bee's knees. Mind you, if I'd spent $25,000 on a valve amplifier, I think I would be convinced that it was pretty good. And you must admit, with all the valves glowing, the mechanics, and it looks like it ought to sound good, doesn't it? It's just a pity it doesn't. Anyway, these were so expensive, but whether I shall build them up using a proper power supply with the correct voltage will depend on what I think of the sound. But I have a feeling I'm not going to be grossly impressed. Sad, because nostalgia. I used to work for Quad years ago, and they were a pretty good company to work for, and they were very conscientious of their products. And apart from the 33 and 303, which is a bloody awful amplifier. I know there's going to be people making comments about this, but it is an awful amplifier. I don't want to go there on this video, but it is not a good, even Quad didn't like it. And I know that for a fact because I worked in the laboratory there, and Quad did not like that amplifier. But they were forced to do it because valves were on their way out. Don't forget to watch out for part 2 of this video, which will be the conclusion after I've spent some considerable time listening to this amplifier and any problems, and basically what I'm going to do. Am I going to throw the boards in the dustbin? Now that's a bit extreme. Or will I use it as part of my system? Watch out for this video. I'll be posting it in about a week to 10 days from today.